Current. This is current and voltage is what we're going to talk about today. All right, we're going to start off with current. Now, current is what I would describe the electrons traveling through a wire, and they're going to be pushed by the voltage. Now, depending on how many electrons you have, the more electrons, the higher the current. But it's those electrons or the current that is the part of electricity that will kill you. It is not the voltage, like most people think. And they say, oh, warning, 50,000 volts. It's really not the voltage you need to be concerned about. It is the current that you need to be worried about. Because current sounds like you could have a small number of milliamps, and it will kill you. All right, it will kill you. So, if you were to say, oh, it's 100 milliamps, or 1,000 milliamps, nobody gets too worried about that, but if you say 50,000 volts, so that's the big thing. It's kind of, I think it's the way human nature is. We're not worried if we know is really small and the number is really small. We don't worry about it. But anyway, so remember, it's the current that will kill you. And it's how many electrons you have going through that wire per second. Now, there are two other things to remember about current. There is what they call alternating current and direct current. Alternating current is called AC. Direct current is called DC. All right, alternating current is just as the name says. The current moves back and forth in the wire. Direct current means it only moves in one direction. Now, you can measure current with an ammeter. Now, most meters today, they will measure your current, your voltage, your resistance. Okay, they're called multimeters. All right, but the piece that measures current is actually an ammeter. Okay, voltage. Voltage is a prime mover. All right, and that means it's the thing that moves the electrons. Remember, we talked about that a little bit before. All right, those electrons are not going to move unless somebody's pushing them, and it's the voltage who pushes the electrons. The meter that measures the voltage is called a voltmeter. That's pretty simple. All right, makes a lot of sense. Now, this picture that you have right here, this is what is referred to as an analog multimeter. All right, and I refer to it as a multimeter because you see that you have ohms up here, actually kilo ohms. That's resistance. We haven't talked about that. That's towards the end of the year. And you also have this one section here. It's AC voltage. Okay, because if you have AC, if you have alternating current, you also have your voltage. DC voltage, milliamps, so that's voltage and it's current. Okay, now why did I use the word analog? When you have what's called an analog meter, all right, that means that it has a needle. This thing right here is a needle, and this piece right here is usually a reflective piece. Okay, like a little silvery tape, or they used to be mirrors. And what that's for is if you're not right on top of this needle, all right, you could actually take a wrong reading. And the mirror, its purpose is if you're not directly on top of it, you're going to see two images of this needle. So you know that you have to move until you only see one needle. Okay, so it's a device to make sure that you're reading it properly. All right, now how do you make or create voltage? There are three basic ways. All right, chemical. You think of chemical, we think of a battery. Okay, and usually with batteries you have some sort of if you're talking about these type of batteries, you have a paste. If you are talking about a car battery, then you're talking about a liquid, okay, being in there. But a lot of times it is going to be a chemical that will carry electrons. Okay, so you got your battery. Magnetic and mechanical. This is actually shows you what a motor would look like. You have two magnets, Notice one is south and one is north. They have the opposite poles. And what's going to happen is that this, I'm not sure what you want to call it, the wire actually, is going to turn. And so what happens is you can see the flow of the electricity. All right, coming right through this. It's called a commutator. Okay, so that's another way. And then what about with light? Light, solar cells today. Big business. The thing is, solar cells still are not technologically where we need them to be to really have them be efficient. But basically the way they work is this. The sunlight hits the cell. Okay, and the little packets of light are called photons. And what's happening here is, all right, it's going to cause the electrons to flow, and then they come through here, light the light bulb, and then back through. The red part is the used electrons, if you will, are coming back. All right, and that's basically how that works. I mean, it's more complicated than that, but I mean that's the gist of it. Okay, batteries. Batteries produce DC, or what is called stored energy. And the two little pieces, if you're looking at a car battery or you're looking at a lantern battery, you've got these terminals on the top. All right, they're posts, if you will. They're called electrodes. If you are looking at a battery that you would put like a C battery, so how you have the little bump on the one end and then the indent on the bottom, they are also electrodes or terminals on a battery. All right, batteries also come in two types. You have the wet cell and the dry cell. The wet cell, it contains a liquid, like a car battery. All right, and this liquid contains the electrolyte. Usually car batteries, they used to use water and sulfuric acid. In a dry cell, it's actually a paste, but they can ooze. So you have to be careful because with that paste, I remember one time lights went out and I'm looking for batteries for a flashlight. And there were some old batteries in the drawer. And I'm trying to put them in the flashlight. And if they're corroded, which means like they're rusty, you gotta be careful because sometimes you'll get the paste on you. I did. It wrecks your clothes. It's just let me put it that way. All right, they're the bad news. So you want to get rid of old batteries. All right, recharging batteries. There's two kinds. When you go to the store, you can buy. Most people buy primary cell. It's one use only. That's it. Okay. Hopefully you recycle when you're done with that, but you get one use. When it's done, it's done. Okay. You gotta hopefully recycle it. The other kind you have, secondary cell. All right. The secondary means you get a second use, if you will, out of it. Actually, more than a second use. Hopefully, many uses. But they're rechargeable. For example, if you have a camera that uses rechargeable batteries, you put it in a docking station, and what it does is it recharges the battery. All right. A lot of times, a common color for these type of batteries is that they'll be green, like the picture is here. All right. You pay a little bit more money for those, but they're rechargeable. All right, battery connections. When you put your batteries in a flashlight and they are, see how you have opposite ends here? Opposite ends. All you have to do is you add those up. All right, most of these are like 1.5 volts. All right, so you'd have 1.5 volts plus 1.5 volts plus 1.5 volts. All right, which will give you what? 4.5 volts total. That's typically what most flashlights run on. Now, if you were to put them, you ever notice that if you're not paying attention and you're throwing, the batteries in your camera or in your flashlight and you don't put them in right and they get end to end, you notice that it doesn't work. That's because the voltages actually subtract. Okay? All right, well that wraps up current and voltage for now. I hope you learned lots, and you have some worksheets that you'll be doing in this section. All right, and if you have any trouble, go back and review the PowerPoint. Have a good day.